Hi everyone, thanks for joining. For starters, I will show the little example application we have here, which is a command line video store. When I run it, it will show us a list of movies and with keys. And the first thing to do is to enter a name. And then it asks us which movies we want to rent and for how long. So for example, I take The Lord of the Rings for 4 days and maybe up for 7 days. And if I then enter a blank line, it outputs the total amount we owe, the amount we owe for each movie, and some points we get for the movies. So that's basically it. We see here the whole application is a single function in about 60 or 70 lines of code, which is in itself a code smell, because usually when we have such a long function, it has things like violation of the single responsibility principle and not a single level of abstraction and so on. So before we start refactoring, the first thing we want to do is to have tests and run a test suite, which is in this case only a single test, which basically passes and covers every branch in this case. So the tests are green, so we can start refactoring. The first thing, if we go to the code here, we have here the part that reads the movies from the file, from this movies CSV file. Then you enter the name, and then we have the loop that reads the movie key and the amount of days you want to rent it. And then it decides, depending on a category we see here in the CSV file, what amount, it calculates the amount, and as well these frequent renter points we saw in the end. So the first thing we could see here is that in these few lines of code here and in these lines of code here above, we have basically the same, we are doing the same, which is splitting a single line into a vector of strings. So this is a code duplication, and the first thing we would like to do is to remove this duplication. Therefore, I mark these lines and select the refactoring tools, extract a method. And in this case, because we are splitting here the movie, I call it split movie. And replaces these lines by call to the split movie function, and it puts the split movie, the function declaration above and the function definition below. And for the repetition of this pattern, I also use refactor extract method, and this one I will call split rental. And it basically does the same. So if I look at the two functions, they're practically identical, but not completely. Here we have different names in it, and the main difference is this character here, which is a blank in the first case and a semicolon in the second case. So the first thing I'd like to do is to make them completely identical. So I rename the line here to input, which is the more generic name, and the to results vector I simply rename to result, and here as well. And then the only difference I have is this delimiter here. So I want to introduce a additional parameter to the function. In this case, I just say refactor extract parameter, and I call it delimiter. And then CLion takes the split rental function, find the usages, and adds the parameter that previously was inside the function and puts it here on the function call. And I do the same here. Extract parameter to delimiter. And then I have the identical function body for the two. So the next thing I can do is take one of the two and name it to split, which is the generic name for the two, and then I could either find the split movie calls and rename them to split, which in this case would be pretty easy because we have only one call to split movie, but the other, the alternative would be just to say return split input and delimiter, and remove these lines. And when we now go ahead and use refactor inline on this one, then it will inline all calls to split movie. And when we look here above, here it says split, which was previously split movie. So we have to clean up a bit. Result is split, and then we can also inline the result variable, and then we have the movie is split. So this was the first thing. Of course, we could have or should have more often run the tests. Basically, the main thing was that all the steps I did here, I could have run the test after each single step, because we just did very simple steps, and we could have compiled and run the test after each one of them, and the test would have been green. So I'll try to use the test more often in the remainder, yes. So next thing we would like to fix is this movie, which is a std vector of strings, but it should be a struct that contains, for example, the data. You see here the movie 0 is the index or a key. Then we have here a name, and a category is the last thing. So we would really like to, instead of just playing around with a vector of strings, and to have a proper structure or class. Using primitives like vectors and strings and integers instead of the proper classes is called the primitive obsession small. To change this in one sweep, we would have to change this map up here, which contains a vector of strings. We would have to change this vector of string down here, and we would have to change the vector of string here, and all in one sweep, which obviously is not these, which would be those small steps I talked about earlier. So we have a strategy we can use here, which is called parallel change, which means we first add a second structure, a second set of variables that contain the new class, and then after that remove the old class. So I add a std map of int and movie and call it movies2. And we see here, obviously movie isn't known yet, CLion to know it. So if I use Alt and Enter, it offers me to create a new class. I want it to be a header only class because it's going to be only a struct. Rename it to struct and hit the test button again. Yeah, it's not declared here, so I have to use Alt Enter again to add the include for it. If I build it now, test will run and because I've not done nothing except adding the new map. Then I want to add the movie here. So the first thing is I want to reuse this key, so I want to introduce a variable for it called key. And then I say the movie should contain an int key, a std string name, and a std string category, which is these regular children and so on. And because it doesn't know std string here, I have to use Alt-Enter again, and it says, yeah, I want to have basic string, and I want it from the string header, not from the basic string header. And then I can go ahead here and say movie consists of the key of, sorry, I first have to rename this old one, which is not the movie, which is only the data we use for the movie, so I call it movie data. And then I can say here movie with key, movie data 1 and movie data 2. And movie 2.insert make pair of the key and the movie. So this is still the parallel change where I have the old movies here and the new movies here. And now I can actually start to, instead of reading from the old movies, read from the new movies. I first run the test again. I have now all write access to the old movies duplicated with the new movies into movies 2. And now I can go here and say, okay, movie.key and movie.name, which is more expressive than just movie data 1 and movie data 0. And then here I have to have the new movie. So I rename this one to movie old. And say auto movie is movies 2. And then I want to have this key again here. Refactor, not a method, a variable key in, and say auto movie is movie 2 key. And now I have here these movie old references. It's the first one is down here, which is the name. The other ones are up here, which is the category. First I run the test again. And then I can rename these ones. Instead of movie old 1, I use movie.name. And now I could either go ahead and rename all these movie old 2 references to movie.category, but instead I want to rename it only once. So first I extract a variable for all 4 occurrences, category, and then I can say here instead of movie02, movie.category, and when I now inline the variable again, they have just extracted, then I have basically renamed all of these occurrences movie02. This is called a narrow change, where we first wrap something that occurs multiple times into one function or one variable, then change this function or variable and then inline it again, so you get this behavior in every place. And this is it for the movie. The only thing left to do is now to clean up the old stuff, the old movie we don't use anymore. So we don't need the movies 2 anymore, or the old movies map anymore. We can remove this one. And I have removed too much. Movies.insert and the old movies map, and then I can rename the movies 2 to movies. And by now we have replaced the old vector of strings with a new movie structure. Run the test again. And tests are green and we are happy. So the next thing to do is basically the same we did with the movies, but this time with the rentals. This time it won't be a structure, it would be a proper class, because we have some logic down here that belongs to the rental data. So first I will rename this one to rental data. And now CLion asked me, it has found usages in the comments and in the in strings, and I will only want to rename the actual variables, so only code usages. And the rental itself should contain the movie and the days we rented it. So I will go down here and say rental. Of course, CLion now tells me it doesn't know rental, so I use Alt-Enter again to create a class, this time a cppn.h class. Class rental. I have to use Alt-Enter again to import it from the header. And now it compiles. And now the next thing to do is say rental with the movie and the days rented, because we want to have the class to carry these data. Of course, CLion now says that this constructor doesn't exist. When we now use Alt-Enter, it says, well, we can create this constructor where I is the days rented. And it's still red because the constructor is generated, but it is private, so we can go ahead and say Alt-Enter again and make it public. And the last thing we need to do, because it's only declared and not actually the defined, we can say Alt-Enter and generate a definition for the constructor. And now to actually have some meaning for the class, we want to have it a movie. And the days rented, and we have to define the constructor, so it says initializes the movie with the parameter and the days rented as well. So we can run the test again. The tests are green. So the next thing we would want to have in this rental class is first here in this block, we calculate the amount that is owed for this single rental. So this is clearly logic that belongs to the rental itself, and therefore we want to extract a function again. Oh, of course I need this one first. And it will be a function that takes the movie and the days rented, which is exactly the data we have in the rental object. So we extract a function. And we see down here, okay, it's called get double because I forgot to rename it, and I just hit rename and call it get amount. So what I'd like to have now is basically move it to the rental class, which is not possible like this, for example, in IntelliJ yet. So I have to go here and move it, and I move it to the rental.cpp. And what we see here in the, I would have expected, or I would have wanted to get the definition in the CPP and the declaration we had above here into the header file, but it doesn't copy both of them into the CPP, but this is quickly fixed. So I can run the tests again. It should still run. And they're green. And the next thing is I basically want to have a function double get amount for a const rental. With alt enter, I can generate a definition again. And for now, this will just return the result of the free function. And the next thing we can do is here, where we say get amount movie.js and JS rented, we call instead rental.get amount, which should still do the same because it calls the same function. This was wrong on the tests. And the tests are green. So we still have this public and free function, but we want this logic to be inside here in the rental get amount function. So it's very simple to just refactor and inline the free function here. And then we have the logic inside the rental class that we wanted to have. So here's just a function call, and the logic we extracted here is inside the rental class. The next thing is basically the same for the frequent renter points, which is a bit more complicated because we have here just a variable that gets incremented inside the loop as often as necessary. But we still can use some small steps here. The first is I can say instead of increasing with ++, I just increase by 1. The next one is I take this one and extract a variable. Only for this one. And I call it rental points. Doesn't matter much because I'll going to get rid of it in a second. So if I add the rental points here in this or after the if doesn't matter, so I can just move it down. But now I can, instead of increasing the frequent renter points directly, I can increase the rental points. And basically have this logic here independent of the rest of the loop and independent of the other variables. Tests are green, so I can factor out a function. And this new function is again dependent on the movie and on the days rented. So I can do the same I did with the getAmount function and move it to the rental.cpp. Put the declaration into the header. Of course, run the tests again. And like I did before, add a new function to the class get frequent renter points. Generate this definition and just define it as call the function with movies. And I have to qualify it here. Run the test once again. And now I can go ahead here and instead call rental get frequent renter points. In this one. And I'm rid of the free function and the logic is inside my rental class like I wanted it. The tests have been green all the time. They are still green. And again, I've done a baby step refactoring with very small steps where I extracted this rental class that takes the days rented in the movie and has this functionality that adds that collects the amount of the rental, the amount of money, and the amount of frequent renter points inside the class. So I extracted this domain logic into its own class. I think we could take a few questions now again, if there are any.
Yeah, there are actually a couple. First, I would actually love to a little bit address myself. So there was a question about running tests automatically after each refactoring round. So I would like to say that actually that's not that easy to understand when you need to trigger the automatic run for the test. So I guess in CLion, there's just one shortcut to run the selected configuration. So it should be pretty much it and quite easy to run the next iteration of test instead of doing it automatically, because that's not that clear when to trigger it. So the question to you, Aaron, is actually is as follows: like, aren't you violating single responsibility principle by just making movie a struct and keeping movie related behavior in the main app?
Yes and no. There is no actual movie-related behavior. This, of course, I'm not done with all the refactoring steps now. This above here is basically inputting the movie data, which could be seen as movie-related, but it's could also be seen as input related. So I'll skip ahead of a few commits right now, and we will see that this input stuff is about the movie gets into a console class, for example, and there are a few other movie-related classes actually that get this behavior. For example, all this reading of the movies out from the stream doesn't go into the movie class, it goes into movie repository. I think it's it would be a good time to skip ahead to see with this refactoring techniques we just used, we can extract a lot of other classes, which obviously I wouldn't get to do in this time. So and so I skip a few commits ahead and just have to reload the CMake project. So what we see here is now the run application after a few of these refactoring steps. We have a console that wraps input and output streams. We have a movie repository. If you look at it here, the movie repository basically does the reading of the movies from wherever, because where the movies come from is not part of the movie logic, it's a different logic. And it basically has like these two functionalities that make it similar to a container. So you get the access by key and you get a list of all movies or a vector of all movies. The next one is a rental factory, which uses the movie repository to generate these rental objects, which is you give it an input string and it does the splitting and getting the right movie from the repository and returning the rental object. And the next one is here, the console prints the movies. We get the customer name from the console, so all these input output is wrapped into the console here. The input customer name is just the prompt and then the input. And after having done all this, we get a pretty clear picture what the run function actually does. It has a console, it has a repository, it has this factory, and it's a very high level of abstraction inside this function, and all the details are tucked away into the different classes. So yeah, on the surface, I did not put the logic of the movie class into the movie structure because the logic of the movie class is distributed mostly in this movie repository, and the input how I create this is no, it's in movie repository. Yeah. I hope that does answer the question.
Yeah, I guess so. So, like, there was another question, like, why to use inline and why not simply let functions separated?
Because often we use these different functions. For example, the free function I had, we could have left it as a free function, but it actually is part of the rental logic. So I inlined the free functions into rental logic. You very often get this you refactor something out of you extract some function or extract some variable, then you move it around and then you inline it again to just move the bunch of logic, the bunch of lines you have extracted in the first place to move it to another place.
Okay, thank you. And I guess the last question for now is a little bit more philosophic, is like, what to do if we don't have a pleasure of having tests in the project. So how to cope, how to check that our refactorings actually works.
Yeah, that's a difficult one because I think it was a quote from Bjarne Sturstrup. If you haven't tested your application, it doesn't work because you can't say it does work. So the first step always is to get the tests. If you don't have tests, well, you have to get the code you want to refactor under test first. That's a prerequisite for any refactoring because if you don't have the tests to make sure you don't break anything, you always have the risk of breaking anything, and then it's the old say, never touch a running system. Don't touch it because you might break it. And so the tests are really essential for this kind of work.
Okay, I guess we could continue further.
Okay, so like you see, we skipped ahead quite a bit. We have this factory for the rentals. We have a rental record which contains all the list of rentals and the customer name itself, and which this total amount function is basically just accumulation of these things we could use, go into the low-level refactoring here and use things like std accumulate here. But there's one final thing I'd like to show. If we go here into the rental class, we still have this if-else cascade about, over the category. And this is another code smell. If you have this if-else cascade over some constant or a lot of switch cases over these kind of constants, this is a smell called simulated polymorphic behavior. So instead of one rental class, we could say we'd like to have a different rental class depending on the category here. So what we can do here, well, first run the test, of course, since we skipped ahead a bit in time. And so we want to have actual, yeah, test don't run because I have some problems with the line endings here. Just let me fix those. Nope. Oh my. Well, I'll go ahead without the test now. I somehow messed up the line endings in this movie CSV, so the actual test won't run again. We have the rental class here. We want to have child classes to this, and so the next thing we do is first just add new classes. The first I would call new release rental. And derive it from rental. We have to use Alt-Enter to get the include. And the rental class, since it doesn't have a default constructor, it does need, the new release rental needs the same constructor we have in the base class. Alt-Enter gives us this opportunity to generate this constructor and just delegates the constructor to the base class constructor. This is the first thing. We do the same for the other two classes. Get the include, generate the constructor, And the third one is the regular rental. And generate the constructor again. So we've done nothing that would change the behavior for now. We can now go into the rental factory that creates these rental objects. And instead of making a rental class here, we can just basically copy this if else. And use it here. If it's a regular, return make unique. With alt, enter the include again, movie, days rented, this one is the new release rental. And this one will be the children's rental. And now we see if we have a different, now we have to determine what to do here. I will just return a null pointer. So we can at least compile them and see that it still works. And we still have the same logic because all these classes derive from the rental class and basically are empty classes for now, where this getAmount and getFrequentRenterPoints methods are in. So the next thing we would want to do is take these two methods and push them down into the derived classes. Refactor and push members down into children's rental. I don't know why this is double here. Into the new release rental and into the regular rental. The getFrequentRenterPoints, getAmount methods. And we push them down. And he says the references will become unresolved because it removes the two functions from the base class, which we don't want, but we currently have no means to let them in here. And since these methods are now in the derived classes and want to access these data in the base class, we can make the data in the base class protected. We could wrap them into getters, into protected getters, or into public getters later to make them private again, but for now this is okay. So what we need for this to compile is still have these two functions in the rental class, but as virtual functions, as pure virtual functions. So now we still have the same logic in each of the derived classes, but now depending on which rental object which actual rental object we have, the derived object will get called. You can see if it still compiles. Test would also still run and be green. And now we can go here and make these two functions a little less complicated, because we know this is children's, so the category can't be new release. So this complete if block goes away, and we can inline this variable. Yep. And similar here, it's a children's, so this is the only block that is interesting for us. The category doesn't interest us. The amount is, well, you see this can be simplified much further. And basically this is it. And you can do the same in the other two classes where it's easy, where we can simplify them similarly. So what we did here was basically a technique called duplicate and reduce. We had like different dependencies on these or different logic in the rental class, and we duplicated it into the 3 derived classes, and then could reduce it for the different cases. And well, that's basically it. I can just, instead of making the manual changes in the other ones, or I can do the manual changes in the other ones. We see here, this is a regular rental, so this one goes away as well. We can inline this variable as well. Here we only have the category block for regular. So all this goes away. This line goes away. And you can start with 2. And have a simpler function here. And the last one is the new release rental, where we do have to keep this if block because we have 2 conditions here, but the first one is always true. So we can remove this condition. And here also we have the new release block. And the rest goes away. We can see here, you can remove this one and inline this, so we get a pretty simple function for this. So this is about it. I'm sorry for the mess up with the line ending, so the test couldn't run for this last part, but I think you can trust me that we had again a lot of simple small steps, and after each step we could have run the tests and the test would have been green again. So this is, I think, the main takeaway, the main technique, to split the refactorings in very, very small steps. So we are always on the safe side and can always roll back just a few minutes instead of having to throw away after 2 days of refactoring like the whole work because we don't know where we messed up our work. So that's it from me.
Okay, thank you, Ernest. So actually, talking about general strategies, so there is the following question, like how do you approach program logic? How do you analyze programs so you can split program into classes and functions? So how do you do that?
I basically try to if we talk about the program logic, we often have like names that are part of our domain language, of our business language, and usually I try to go a bit in the direction of domain-driven design. So if I have a name like the rental we had, or the movie, or like we had in the output the rental record, these are indications that that we need classes for these different concepts. And then usually we see quickly that there's logic that belongs to this concept as well. For example, if you have the nouns, which would be the classes, we usually have some verbs, which would be the methods of these classes. So we have to gather this logic into the classes. So the main thing is first identify the data that belongs together and put them into the classes. Then it identify the logic that belongs to this data, extract it into methods, and put these methods into the classes, like we did with the rental class.
Okay, thank you. So there is one more question, a little bit more detailed, like why the movie in rental is a reference instead of a copy.
We could have used a copy as well. In our case, the movies are constant. If you would have like movies that change over time or so, then the reference would account for that. That we have like the changed movies always referenced the changed movie, or we could have a copy to only have the movie like it was originally. So this is a decision we have to do, which is coupled to the domain logic. But in this case, since the movie is constant, I just chose a constant reference instead of a copy.
Okay, thank you. And there's also a comment about comment in the code, actually. So, like, because you removed all the commands, and so the actual listener is interested, like, because people are usually not doing commands, but that's actually not very good, you know.
You mean like the removal of comments? Yeah, the comments we had in the function in the beginning were basically also hints for blocks of code which belonged together, which formed like well, when we extracted them into functions, then the function name basically is set the same as the comment. So then the comment becomes redundant and we can remove it.
Okay, thank you. So I think this is mostly, there were a couple of questions about the strategies you were mentioning and like the names and the useful links. I guess we'll collect them all and put into the final blog post with the recording so that everyone could find them easily. So you could just expect it inside the blog post. So this is mostly it. I will switch to myself to say a couple of final words.
Okay.
So actually, thank you, Arne, for presenting. And we are again sorry for some technical issues with the blanking screen during the first part of this webinar. Things happen, unfortunately, sometimes. So here we are with some useful information. As I said, the video recording of the webinar will be available in a couple of days on our JetBrains YouTube channel, and we'll announce it via our social media and blog. So feel free to provide any feedback to JetBrains and Arne. And if you'd like to know more about CLion, just go to jetbrains.com/CLion. And if you'd like to learn more from Arne and read his refactoring dedicated blog post and the rest of his blog, so it's just the arne-merz.de. So thanks everyone for joining us today. If you'd like to learn more about upcoming webinars, just subscribe to our Twitter. We'll be happy to have you the next time for the webinars. Thank you and develop with pleasure.